6.4 differential equations with piecewise defined right-hand side. And we have already introduced the step functions last time, so today we will just use that technique to solve it. We will just do it by a few examples. Okay, example 1, y double prime plus 4y equals, let's make the 3 segment. T is less than 5. Then here is t minus 5 over 5 when t is between 5 and 10. And then after that it's 1. So if we plot it, you will see it's 0, then change to 1, right? And it's linear. When it's t equals 5, it's 0. When t equals 10, it's 1. Okay. So it's continuous actually, but it's still piecewise defined. And the initial condition, we just make it easy. They're all 0. Okay. So in the first 5 seconds, nothing will happen because start from 0, stay 0. So let's write down the equation. I mean the transform. And that is because everything is 0. It's really simple. It's just s squared plus 4 times y. Right? That's nice. And the right hand side. Okay. Before that, we have to write down the step function form. So nothing here. Then have u5, and the change is just that because you start from 0. Then you have another change at a 10. And this time you need to write down difference, and difference is 1 minus that. Right? Or you can simplify this a little bit. This becomes 5 plus 5. It's 10 minus t over 5. Alright, so let's see what we have. The first term, you have e to the negative sc, which means 5s. Then, do you remember what to do? You have to write down the transform of, you replace t by t plus 5. And this t by t minus 10. Right? So this is t plus 5 minus 5, so just t over 5. And this one you have e to the negative 10s. Then you have to do t 10 minus that, so 10 cancel the 10. Oh, sorry, t plus 10. So 10 cancel the 10, you have negative t over 5. Right? Then you have e to the negative 5s. Then this is 1/5. Then you have 1 over s squared. Then you have negative 10s, same thing, 1 over 5, then 1 over s squared. Alright, so let me put together. So our capital Y must be 1 over s squared plus 4, right? It's from here. Then you have 5s squared, then e to the negative 5s minus e to the negative 10s. Oh, sorry, let me guess here. Okay, so, and this is a product, so we have to write down partial fractions. Just here. So you have s squared plus 4 and s squared. Well, it might be easier to switch them. S squared plus 4 here, and you will see why, because I can just put 1 and a 1 here. What do you get? Yeah, s squared plus 4 minus s squared, which is a 1, or which is 4, right? So if you divide it by 20, you get a 1/5. Okay. Then you have e to the negative 5s minus e to the negative 10s. Alright, let's see. We're done with the capital Y. Let's do the little y. You can recover it step by step. 20 is kept there. Then you can regard it as this times e to the negative 5s, and then do the negative 10s later. Okay. So if you have this e to negative 5s, it means you will have u5. Then how do you do the shift? You have to do inverse transform. Then you replace t by t minus c. Right? And similarly, you will do, this is minus, so it's minus u10 of t. And then you do the same inverse transform, but you replace t by t minus 10. Okay, so let me put together u5 of t. What did this give you? You have t minus, then this is a 1/2, you know, right now this is 2 times a half, right? And this gives you the sine part, sine of 2t, like that, right? Now, be careful, I replace t by that. T minus 5, t minus 5. Alright, then you have minus u10 of t, and everything is just similar. Okay, so that's your result. There's not much to simplify because you have, you know, sine of 2 times t minus 5, not t times t minus pi. So that's it. That's what you will have. Okay, now let's see another example. Let's say y double prime plus 4y equals sine of t minus u 2 pi of t times sine of t minus 2 pi. Well, this sine of t minus 2 pi is to make your life easier. You will see why. And also, let's say this is 0, that is 0, just also to make your life easier. Okay. So your equation is still pretty simple. It's still the same left-hand side. And the right-hand side, what is sine of t? 1 over s squared plus 1. And u of 2 pi will give you e to the negative 2 pi s, right? And remember, what do you do when you do this part? You replace t by t plus 2 pi. And now I just cancel the negative 2 pi, so you just get sine of t. And sine of t will give you that, right? So if you don't have this negative 2 pi to start with, you have to, you know, replace t by t plus 2 pi. But anyway, it's the same result, so it doesn't matter. So what is y? Y equals 1 over s squared plus 4 and 1 over s squared plus 1. Then you have 1 minus e to the negative 2 pi s. Right. Okay, then do the split. 1 over s squared plus 1 minus s squared plus 4. And you can see the numerator would be 4 minus 1, which is 3. So we times 1/3. Right. So that's very similar to what we had earlier. And we can write down your result pretty much directly. Okay, let me do this again. This is 2 times 1/2. So this will give you the sine of 2t. Right. So what's your solution? 1/3 is the common part. Then this gives you sine of t minus 1/2 sine of 2t. Right, that's for the one part. Then for this part, where you have u of 2 pi of t, then you have to do the same thing, but replace every t by t minus 2 pi. Right, that's it, but you can simplify it because sine of t minus 2 pi is same as sine of t, and sine of 2t minus 2 pi is same as sine of 2t. So this is identical to what we had earlier. So it's just a sine of t minus 1/2 sine of 2t times u1 minus u2 pi t. So if you can simplify that, even better. All right, let's do one more problem, then just do your homework. So this time we will have y double prime plus y equals, you start with 1, then becomes 0. And this time, because the equation is pretty simple, we will make your right hand side, and you make the initial condition non-zero. Alright, so let's see what we have. The left hand side, because of this non-zero term, you have -1 to start with. Then, because that's still 0, you still have that pretty simple thing. And what's the right hand side? You start with 1, then you have a uc, which is u pi of t, but the change is -1, so this is minus. Alright, so then you do the transform, you get 1 over s minus e to the negative pi s, and what do? This means it times 1, right? And you don't need to replace anything in 1 because it's a constant, so it's still 1 over s. Okay? So let me move this 1 there, so we have s squared plus 1 y equals 1 plus 1 over s minus e to the negative pi s 1 over s. Alright, so what is y? 1 over s squared plus 1 plus 1 over s squared plus 1, and 1 minus e to the negative pi s. Alright? And you can do the split. And how do you do that? This is s squared plus 1. You can see if you put a 1 in s here, what do you get? S squared plus 1 minus s squared, which is exactly 1. Okay? Negative pi s. Alright, so we are pretty much ready for the actual solution. This will give you sine of t, and that will give you e to the, sorry, not e, it's 1, right? 1 minus, that's cosine of t, and that is for the 1 part. How about the exponential part? You have minus u pi of t times, the only difference is that you have to replace this t by t minus pi. Right? If you want, this is not cosine t, this is 1 plus cosine t. Right? So you can just write down the solution in that form. Okay, I think that's it for this chapter, and you can just do your homework.